about sidecars and what they actually do for you. Sorry about that. So why this talk? First, because there's been a lot of talks around service mesh, sidecars, not sidecars, etc. And I was looking around, I couldn't find real content that actually focuses on what like sidecars actually bring. And so I thought I'd try to do it. Like maybe I'll fail at it, but who knows. There's probably 3 different types of people here. People that know nothing about service meshes, and you might get something out of by just learning about it. If you're never planning to use a service mesh, doesn't matter, it's just culture. The second type of people are people that are using a service mesh or planning to use a service mesh. Whether you're using Kuma or not, doesn't matter. Service meshes do look quite similar, and you'll get something out of this. Like you'll learn a little bit about the internals of things and how things actually work. And finally, if you're already using if you're already a user of Kuma, this will bring you some of the tools that enable you to troubleshoot things and understand how things work internally, and you'll be a better user. So the service mesh architecture, if you take something like Kuma, it's like that. It's very big, it's multi-zone, it can do VMs, it can like talk between zones, external services, etc. But that's a little bit too much to digest in this talk. So we'll go in the most simplest architecture of a service mesh. So we have a control plane, that's in some ways the brain about it, and then we have services. Services have instances. In each of these instances, they're going to have a sidecar next to it. All the traffic that come in and out of this instance will be routed through this sidecar. This sidecar is a proxy. In the case of Kuma and in the case of a lot of service meshes, this sidecar ends up being envoy. What happens is the sidecar will connect to the control plane and receive configuration from it. We'll go in a little bit more details about that in a bit. In practice, if you're running on Kubernetes, the combination of a sidecar and your app is a pod. So what we do is when you start your service, we intercept the pod configuration, inject the sidecar configuration, and then start. It's all invisible to you. So why a sidecar? That's the right question. So it's a simple security model in that if you're already running on Kubernetes, the concept of a pod is something you've looked into it, right? It might be imperfect. It doesn't cover all the cases, etc. But it's something, a trade-off you went for it. If you're adopting a service mesh on top of that, you don't have to rethink that because the sidecar actually just lives in the pod. The second point is that multi-tenancy is super hard. It's one of the most complicated problems in computer science, and containers did an okay work about it, and Kubernetes added the layer on top of that. So what you're doing by that is you're building on the shoulder of giants, as in you don't have to reinvent. Like if you have a proxy with a lot of different services on top of it, you're gonna have multi-tenancy problems and stuff like that that you might have less of if you're running with sidecars. Then it has a great failure isolation. By great, I mean it's a failure isolation you actually know. If your instance goes down, that's something you already know what happens when an instance goes down. If you have a proxy in the middle, what happens when this proxy in the middle actually fails? In our case, it's just like losing an instance to lose a proxy. So that's kind of nice. And then in the way you scale as well, you scale in a single dimension. Instead of scaling on one way on your proxies in the middle and the number of instances of your proxies, like if you have an API gateway or something like that, and then on the other side, on the downstream, so the number of instances, you actually scale in a single thing, the number of instances of your app, which is a lot simpler when you're trying to scale and think about sizing. And then finally, upgrading your sidecar is just like upgrading your app. It's something you're already doing, restarting your app. That's something you should be doing. That's something that's pretty at the root of Kubernetes. As in, if an app fails, if you need to restart your node, killing a pod and recreating it is at the fabric of Kubernetes. So doing that for your sidecar shouldn't be a problem. This has been covered in a lot more detail in this blog post down there by William Morgan. And I warmly invite you to read about it. So what happens between the control plane and the sidecars? So the sidecar will connect to the control plane. It will send what we call token and metadata about the identity of the sidecar. We will verify this token. In practice in Kubernetes, this token is a service account, so it's already there. You don't have anything extra to do. And we'll generate the sidecar configuration from the state of the mesh. So what is the state of the mesh? The state of the mesh is the policies that apply to your mesh. So things like timeouts, certificates policies, and we'll get in more details there. And then the different services and instances inside this service. We'll take all this, build a configuration for the sidecar, send down this configuration down to the sidecar, and transparently reload this configuration. Transparently reload is the important thing here. That means you can change a timeout somewhere, you can change a connection pool, and it will happen without you actually realizing it, without needing to push a restart button. So when things go badly, operationally, there's no moment where you think, well, there's a configuration to control my connection pool, but actually I do need to restart my entire fleet to be able to update that, and things are already going pretty wrong, so do I want to restart my entire fleet right now in the middle of an outage? Well, you don't have to do that. This happens transparently for you, and it's done pretty well because it's Envoy. So whenever the state of this mesh changes, we'll actually update the configuration and set it down. So I'll do a little segue here because I need to introduce a tool to be able to go into the examples later down. So Envoy has a pretty complete admin API. You can do everything in this admin API, so much that you can actually shut down the sidecar from the admin API. So it's not something we want to expose to people. So what we do is we expose a subset of this API through our CLI and through our user interface. There are 4 types of APIs. There's the policies API that gives you the list of policies that actually apply to your sidecar. You get the config dump API that gives you the full configuration of Envoy. It's very verbose, but sometimes it's the best way to actually figure out the toughest problems. You've got the stats API, which is more or less the stats of your sidecar. And then finally, you have the clusters API. What's called a cluster in Envoy is more or less a service in Kubernetes. And then for each of these clusters, there are endpoints. Endpoints are instances behind this service. So what you do with this clusters API, you actually see pretty detailed stats about the data going to your services and to each of the instance, which is quite useful to troubleshoot problems as well. So we'll use these APIs through the rest of this talk to actually figure out, to showcase some of the features of this. So the first one is mutual TLS and certificate rotation. So everything you do in a service mesh to actually enable MTLS is actually write a bit of config like that, apply it, and then you have MTLS everywhere. On this MTLS, you have a rotation that here, for example, is going to rotate the entirety of your certificates of your entire mesh every day. I don't know if anyone tried to do MTLS like without something like service mesh. It's pretty tough. So how do we do that? A control plane, like whenever the sidecar connects to the control plane, will issue a certificate. This certificate is only valid for the lifetime of this sidecar, right? Every time a new sidecar connects, we actually create a new certificate. In this certificate, we use the SAN to actually put what we call SPIFA IDs. So SPIFA IDs actually is a format that is a standard, it's a CNCF project, to actually identify a workload. Then whenever a server connects, client connects to a server, it's going to be better that way. A client connects to a server, each of the side are going to be able to verify this SPIFA ID and check that they are actually allowing the traffic this way, right? So the client is going to check that the server is actually the server that they want to, but the server will be able to precisely identify who the client is. This is all on my service mesh. Like, you don't really have to roll that yourself. You don't have to distribute identities and things like that. It just comes for free. And then, as I said, certs are going to be renewed automatically before the expiration. So if we look in the weeds and we look at the configuration, you can see here that we use this secret default. So it's the certificate that we've issued. And then we're going to accept connections that come from SPIFA default, which is the name of the mesh. So we're only going to accept connections that have in this SAN that starts with a SPIFA default and are issued by the CA, secret default. Default comes back everywhere, but it's the name of the default mesh. You can actually see it here in like metadata name default. So, and then if we look at the certificate, we can see it's actually valid for a day, like September 9, September 10. So the next thing is CA rotation. It's almost as easy. You actually add a second CA, right? This CA is distributed everywhere. New certificates are actually issued on this new CA. And while everything is rotated, when everything is rotated on the new CA, in our previous cases, at worst 1 day, you're actually able to remove the old CA. Like, rotation of CA was like even harder than MTLS because it was very hard to track everything. And this is just super easy thanks to that. So how about metrics? Like, this is probably the most common use case to use a service mesh, is trying to have common observability. But common observability is not limited to the proxy. So what we can do is to actually scrape metrics of both your proxy and your application and expose it in a common format with the same labels. This is quite useful because then, regardless of whether you're running on Kubernetes, you're running on VMs, etc., your metrics will look the same. Reusable tools, like this is pretty important there. And then also, you definitely don't need to expose any of the application support to the outside network. Everything is sheltered by this Envoy proxy. And then endpoint discovery and load balancing is the next thing. So if you're using Kubernetes already, you're using something that's called Kube proxy. So what Kube proxy does is more or less take all the endpoint and round robin between them. It's okay, it works, like it's satisfiable for some people, but it's quite likely that you'll want to do something more complicated. Like, for example, being able to write traffic policies that need to know which endpoints, because they'll need to keep stats per endpoints and things like that. So whenever we add a pod or a pod goes unhealthy, etc., we're going to reconfigure the configuration of Envoy and push it down. This happens pretty quickly, usually under 1 second, and then you can configure a bunch of things. So here, if we look at our inspect API and see the clusters for this service, RSRV0 Kuma test, you can see there's 3 different endpoints at the end of that, 22, 23, and 24, and they all receive 23 requests. So if we take one of these examples of policy, we'll take outlier detection. The advantage of outlier detection is that it will evict, stop sending traffic to a client if we decide that this client is an outlier. There's multiple ways to decide that, but in our case, we're going to say if more than 15% of the requests to this client are actually bad, we'll stop sending traffic to it until it heals. Like, this can be useful, for example, if you have a stop the world GC in the middle or something like that, and you start returning errors. If you keep the client for a little bit, it might rejoin and everything will be happy. So here, if we take our 3 clients again, you can see the first one has 100% success rate, and so it's healthy. You can see the second one is actually an outlier because it has an 81% success rate, and the third one is 90. You can push it a step further by having a 5% threshold, and now you have 2 clients, 2 endpoints that are actually kicked out. So the one thing when you do that is pretty quickly you end up shooting yourself in the foot. You do this thing, and you set things up, and you say, well, I'm going to do this, and then you have a pretty dramatic failure. So for example, the database downstream is actually down or something like that. And then is returning 20% of failures. And so you have 20% of failure everywhere, regardless of the endpoint. So you kick out all the endpoints, and now you have 0% success because you've kicked out everyone. You have no one to talk to. So what comes great with Envoy and things like that is that you can't shoot yourself in the foot because it comes with all these parameters. So in our case here, it's a max ejection percent. If 50% of the endpoints are actually considered invalid, we'll decide that the outlier detection is not effective and actually ignore completely the outlier detection. This is great because then you save yourself from a worst outage. So in conclusion, sidecars implement pretty complex algorithm. They're very mature. They've been built, like the Envoy community is pretty big. The number of bytes that's been through Envoy is like mind-blowing nowadays. So you'll never be able to do better than that. At least, like, I mean, I don't know where you are, but who you are, but it's very likely that you won't be able to do better than that. So you should build on the shoulder of giants. The next thing is if you evaluating service meshes, do be careful to compare apples to apples. We have sometimes evaluations where people say, well, there's a cost to service mesh, and it's true, there's a cost to it. But sometimes it's so extreme that they compare their current infrastructure that has like no MTLS whatsoever to a service mesh with MTLS. So it's like, yes, there's a cost. You're doing encryption. You were not doing encryption before, right? And it's also very important to consider what is the value that you're getting from that. Like we've seen a lot of customers that improve their failure rate and things like that. And these are directly impacting things that you might not be like just counting in latency, in pure latency or pure CPU. And then finally, if you use Kuma already, do use Kuma Control Inspect and the GUI that goes with it. It has a lot of information, and like the dev team uses it all the time. And yeah, we even asked for output of that in issues and stuff like that. So that's about it. So if you have any questions.
Thank you. Are there any question about sidecars and service mesh? I have some if you don't have.
I see there is, so it's supporting already the MTLS, but there is the cases when between two microservices, we part in the zero trust. So we want to generate a token and be verified later. Is there a mechanism to generate and verify automatically with policy?
To generate not so much. To verify, yes, there are extensions, like you can use things like OPA and stuff like that to do this.
Even in Voya, there is a configuration to verify, but what I look for is generation. It's the service mesh permit to generate with scopes and authorization.
Right. Yeah. So, yeah, that's not something you'd be able to do right now, as far as I know.
Thank you.
Another question? Yes, no? I may have one. I've seen, so there are many configuration possibilities for regulating the communication between the sidecars and especially the instances. Is there a place where people can find kind of ready-to-use configuration so they can avoid them trying to reinvent the wheels?
So you mean for specific use cases like reusable configuration?
Yeah.
I mean, there's quite a few examples in the docs and stuff like that, but there is no so much like library of like, hey, you want a timeout, like just use this timeout. It's tricky to build like very like easily reusable things like that, but yeah.
Okay. Thank you very much.